Hello, my name is Will Chaparro, and I'm here to talk about architecting hybrid cloud solutions with the Watson Developer Cloud. We needed to innovate. IBM Watson was releasing 7 cognitive services, and our product management team wanted to understand how these services could enhance our existing on-premise search solution. The only problem was these services were in the cloud, and our solution was an on-prem solution behind the firewall. So we couldn't just take a library and add it to our installation package. We couldn't just take our existing on-prem solution and put it right onto the public cloud. So we had some difficulties there. So what we did was we created a hybrid cloud solution that allowed us to innovate with these cognitive services in order to develop a solution that provided our users with a innovative capability and allowed us to innovate in areas where we did not have the expertise. And this was an on-premise to public cloud solution. So before we go any further, why don't we go ahead and talk about some definitions. So cloud computing is it's a model for enabling convenient, on-demand access to computing resources that can be rapidly provisioned or released on demand with very little management intervention. There are 4 cloud deployment models: private, community, public, and hybrid. There are 3 cloud service models: software as a service, for example, Microsoft Office 365, infrastructure as a service, I'm sure you're well aware of Amazon AWS, platform as a service, so things like Heroku, IBM Bluemix, and the Google App Engine. This sounds very, very familiar, if anybody remembers. So let's also go over a definition of hybrid cloud. Hybrid cloud means that the design spans more than one cloud. To be more specific, it is the connection of one or more clouds to on-premise systems and or the connections of one or more clouds to other clouds. Why the heck would you use a hybrid cloud solution? So one reason is for compliance. There's typically security assets that you may not be able to move into a public cloud solution. And so a hybrid cloud will actually allow you to protect those assets in order to provide a better solution to your users and to protect the security of that information. Bursting, so the ability to scale and to elastically increase your capabilities based on increasing or decreasing workloads. So this is about expansion and contraction. Transition to the public cloud. So there are many cases where you may have existing investments. You may have security reasons why you cannot transfer to a public cloud. And so this hybrid cloud capability actually allows you to transfer in bits, in pieces, in a safe, controlled way. There are some other reasons as well. Disaster recovery. Obviously, we already talked about scaling, cost optimization, geographic optimization, the ability to cover legacy system gaps. In our case, it was all about innovation. Hybrid cloud allowed us to very easily integrate with a solution that provided us with new capabilities. It provided us the ability to take these steps slowly, and it also allowed us to quickly get up a solution that would allow us to start thinking about what is it going to take our solution, our on-prem solution, to the public cloud. So let's step back and try to understand some of the innovation capabilities that we encountered with the Watson Developer Cloud. So in its never-ending quest to beat nerds, IBM created a computer that in 2011 beat the best of the game show talent by winning the game show Jeopardy. And in 2014, IBM decided to go ahead and release a lot of these these cognitive tooling capabilities into a service called the Watson Developer Cloud. And so we were lucky enough, our team was lucky enough to actually get a chance to integrate with these services. There were only a couple problems. We had no experience in machine learning. We had no experience in cloud computing. We had no idea what these services did. And yet we still needed to innovate. We needed to innovate quickly with minimal investment and with a reliable technology that we could count on. So we created a hybrid cloud solution. This allowed us to innovate quickly with the capabilities of our team and with a solution that we could trust. And we used the Watson Developer Cloud on Bluemix. So what is the Watson Developer Cloud? So IBM takes these cognitive tooling, they release it as a collection of REST APIs and SDKs, and they hosted it on a platform called IBM Bluemix. And IBM Bluemix is a typical platform as a service offering, very similar to Heroku or some of the other cloud services, which provides things like boilerplates, like runtimes, and other integration points. And so our investigation, when we first started looking at this, there were 7 different services that we could integrate with. And these services were all, at the time, they were all in beta. We started investigating them. We started understanding what they did, what capabilities they had, how we could use them, what the use cases were, as well as trying to understand how they could integrate with our existing on-prem solution. Our approach was to basically take a look at our toolbox, pull out our hammer. In our case, our hammer was search. We needed to focus on the user. We needed to understand, what were the use cases, what were the user experiences that we could use that would have great advantages to our customers. We experimented with these services. We learned a lot from them, and we started to share that knowledge with our team and with some other teams. And of course, we did take a lot of these practices, we documented them, and provided ways of sharing that knowledge with these other teams. So if we go ahead and take a look at the actual solution, let's take a look at a couple examples of this. So one of the services, probably one of the more interesting services, was called Personality Insights. Personality Insights basically would take a passage of text, for example, like Twitter tweets, and it uses linguistic analysis to infer cognitive and social characteristics. So a person's likes, dislikes, big 5 needs and values. And so we took that service and we integrated it with our existing on-prem solution, which you can see with that we call the application builder. We created a proxy to enable AJAX-style interactions with the user's browser. And then we created a couple of RESTful services on Bluemix that integrated with the Watson Developer Cloud to process these requests. And so we rendered the output in a user's browser. Oh, yes, and of course this is an on-premise and public cloud interaction. So we rendered these interactions, these output into a widget that allowed the user to see, okay, what are some of the insights that we have for this particular Twitter user. And we handed this over to a UI team. The UI team did a better job than we could as far as creating a nice visualization. This was eventually added to a demo for a IBM conference and ended up becoming a Watson product. And so that's really exciting, super, but it's more interesting, what were the lessons that we learned from this experience? We found a number of reusable patterns that we could use for further integrations. We found a number of key quality attributes that were extremely useful to us understanding this hybrid cloud interaction. We definitely understood a lot of the benefits that we could get from hybrid cloud integrations, and we certainly had our share of challenges along the way. So I'm sure this is pretty easy I'm sure everybody in the audience knows this. So architectural pattern, right? Architectural pattern is a general reusable solution to a commonly occurring problem in software architecture within a given context. We discovered 5 integration patterns. One was asynchronous interactions between the user's browser and the RESTful services. We've found server-side interactions, which were basically upon page load, the integration with the RESTful services occurred at that time. Query time, so during query parsing and processing, we would interact with those services. And then crawl time, during the process of ingesting the original data in a search application, there's a series of steps that it takes to get to a state where we can actually index it. And so the crawl time integration involved insertion of one of the services. And then pre or post processing. So using our APIs, we could batch process some of the content. And if we go into an example pattern, let's take a look at the crawl time interaction. So typically a crawl time interaction would involve looking at existing documents. We would want to understand more about those documents. So we would do things like we want to pull out entities, so entity extraction. It was important for us to know, in some cases, sentiment analysis of the documents. And in some cases, it was important for us to understand, what are the characteristics, the relationships between some of these entities as well. And so a simple crawl time pattern follows a pipe and filter. We would basically take the crawled HTML in this case, or PDF documents, or Word documents, and then pass them through filters until we got to our custom integration. And this custom integration would then call out to our REST-based services to enrich the data that we retrieved. And so very simple crawl time integration. What quality attributes did we find with this implementation? Quality attributes, benchmarks that describe a system's intended behavior within the environment in which it was built. Thank you, Wikipedia, very much. Okay, so key quality attributes that we found. Data protection and security were extremely important, especially when we were looking at user data. So that was certainly a factor in how we constructed some of these solutions. Scalability and elasticity are certainly not the same things. While you may be able to scale and support large numbers of users, it also was important for you to be able to understand when your resources were not being used, and thus bring the usage down or up as needed, based on the usage of the system. Interoperability was also extremely useful. We needed to be able to operate between each of these different systems, and so having a reliable API that could facilitate that was extremely important. So let's take a look at some of the quality attributes for the personality insights visualization that we showed. The personality insights integration was actually computationally expensive, not only in cost but also in the length of time that it actually took. So when designing the systems, we needed to understand, okay, would it be valuable for us in production implementation to cache some of this information? So we're needed to think about certain tactics to alleviate the costs there. And obviously, security and privacy. Sure, we were looking at Twitter APIs, which are public. That information was public. But what if we had been looking at emails, private emails, or any other type of communication? Obviously, if we were integrating with a public cloud solution, that was something that was extremely important to us. Looking back at the crawl time pattern that we had seen earlier, some of the concerns we had there, we noticed a significant increase in crawl time. So when you're looking at providing a performance quality attribute scenario, you need to take that into account. There's an increasing amount of impact in the crawl time. Certainly can impact SLAs and things like that. The other aspect of this, what happens if our licenses run out, or what happens if a call fails to occur? So how do we build in some type of reliability to this integration? Things like retry, caching, or perhaps we even look at targeted enrichment. So we don't enrich all the documents that we're crawling. We enrich only those that may have extreme value. So maybe we only enrich PDF documents or certain web pages under a certain domain. Certainly some things for us to think about. So to review, the benefits, compliance, bursting, the obvious transition were all very key factors. And for us, it was really about being able to innovate quickly. Has anybody here heard about Roman writing, or heard the term Roman writing? Nobody? Nobody? Going once, going twice? Okay. So IBM asked a number of cloud technology experts to sketch out their thoughts on hybrid cloud. Adrian Cockcroft of Netflix provided this example. His example basically said, hybrid cloud is Roman riding. If either horse trips, you crash. So that's a guy Roman riding right there. He's making it look pretty easy. But the reality is, hybrid cloud implementations are not easy. Coordinating combinations of private and public cloud with possible different functional stacks, with different SLAs, different security requirements, is certainly not an easy task to control. And most of the time, the horse is going to end up looking better than you are. So there's a new set of challenges within this domain. Certainly new technologies, new sets of problems. This is a paradigm shift. This is a paradigm shift not only for developers, it's a paradigm shift for QA teams, ops teams, and especially for architects. There's a reliance on something you have no control over when you're looking at some of these hybrid cloud implementations. You have to assume that it's not going to be available. You have to assume that it's going to crash, the network's not going to be available. And it's the Wild West, so be careful of cowboys. So as we went on our cloud journey, we definitely encountered a number of things that we thought was, we basically did not understand the immense complexity of these hybrid cloud-based solutions. Once we started doing these experiments, these innovation experiments, we learned a lot more about it, and we had a better understanding of the complexities and actually the real value of what we were doing. The real value was that we were actually taking these implementations as a starting point for moving to a cloud-based solution. And so it was great for us to start this journey. So to conclude, you will introduce architecture complexity when moving to a hybrid cloud. Hybrid cloud allows you to handle increased workloads, but keep the safety net of being behind the firewall. And hybrid cloud offers organizations a phased approach for transition to the cloud. So all the integrations, all the work that we did is actually available out on GitHub under the Watson Explorer organization. So there's sample code out there in a variety of different languages that you can integrate with. And there are also a number of repositories on the Watson Developer Cloud on GitHub that will also enable you to get up to speed and moving very quickly. In fact, there's a capability on some of those integrations which are just basically pushed or click to deploy. So it'll deploy it directly into Bluemix, and you can start working on an integration. There's some references here. There's a nice infographic that Microsoft has put together that describes a lot of the design patterns with cloud technologies. References, some more references, a lot from good stuff from Netflix OSS, OpenStack, Bluemix stuff, and Azure. So thank you very much.
Thank you very much. So we have plenty of time for questions. If you want to. Well, he raised the hand first.
So one question I have is that, I mean, when you decided to do your hybrid cloud, I'm sure you had to make some trade-offs from the, I guess, private cloud type of situation. So what were those trade-offs you made, and then what did you do to overcome those potential issues due to the trade-offs?
So some of the trade-offs, we had no control over some of these integrations. So the endpoints, in some cases, were not always available, or especially when we were looking at a beta integration, or some times when the services were not available. And so it was actually a great practice for us, because then we started thinking about, well, okay, what do we have to do if these services are not available? So caching, as an example of things that we of a tactic that we used in order to satisfy that.
Your main quality attributes are like performance and security. Okay, so when you do that, like bursting requirement. If you have a bursting requirement, we are moving to hybrid cloud. But at the same time, performance is the key quality attribute if you are targeting. That case, what would be that? What was the challenges you faced? Is like, because we may need to have the sharing, data sharing between cloud and in-house platform. That case, actually, we may end up in having a performance issues and security issues. But the bursting would be the primary target for it. But how to, especially again, it's in line with the same thing, trade-off. But how to handle those kind of challenges, because we need this and we need this as well.
Those are trade-offs, yes.
Yeah,
So
yeah.
you have to make a decision, right?
Yeah.
And it's not always an easy decision. You have to get your stakeholders in a room and analyze the various trade-offs, and then find a way to come to an agreement. And there's not always going to be a technical solution in some cases, especially if you're limited by the performance of one of the integration points.
So in your experience, like, how was that, what was the distance of the cloud and in-house? So that if it is in two different geography, definitely that plays a major role in this performance.
Yes, ask me that question in 1 year. We'll get to that. Yes. I don't really have an answer to that question with full confidence at this time.
What was the CMP you used for it?
Sorry?
Cloud management platform, what was that?
So we're using Netflix OSS. We're using Cloud Foundry for management of the services. Yeah.
What if we don't have the private cloud? Like, can we use it without private cloud?
Yeah, so hybrid cloud is a combination of public to public. Could be public to private, could be public to on-prem. Bluemix is actually offering so a lot of private cloud on-prem solutions. So you can have a cloud within your behind the firewall, basically. I think they're going to offer the Bluemix on-prem this summer. But public to public is certainly an option. The only thing you have to be concerned about, so if you're doing public AWS to public, I don't know, maybe Microsoft, obviously you have to be concerned about the management of those two different cloud platforms. If they're on different stacks, that creates a lot of complexity.
So for private, what hardware do we need for the private to install within Bluemix? Is there hardware requirements or what do you about?
So in most cases, if you're doing a private cloud offering, whatever your IaaS provider is going to provide you with the hardware. I know that IBM does offer that capability. I don't know what some of the other service providers do or not. So.
So, 1,
First, thanks for the talk. Very informational. Have you guys experienced the use case where in the private cloud, the data can't be in the public cloud, but it can't also be processed outside of the firewall? So, and I know you have a lot of crunching services. How do you manage that? So I can't get the data even out. It has to be processed
So it can't be out of the private. So I think there's some solutions where you can use some type of a service bus in between the private and the public. In other words, you're keeping the data encrypted on the public cloud solution, but your keys are present on your private cloud. And then you can use a service bus to then retrieve the keys, unencrypt the data on the public cloud for the period of time that you need it for the user, and then move on. And then so that the data is kept encrypted on the public cloud, but the keys are kept secure in the private cloud. And so there's a couple of ways to do that through service buses.
But in that case, the data still has to move through the pipes.
In that case, yes, the data would have to, right? So you are going to have to implement some type of a custom service bus to get that data out, but do you really want to get that data out unencrypted? Probably not.
Thank you. Next.
Couldn't you just use a private cloud or virtual private cloud? It's not clear to me why you couldn't do that.
For this solution?
Yes.
Currently, the Bluemix capability did not offer a private on-prem access to these services. So there was no Bluemix on-prem at the time when we did the integration. Now that's coming out in the summer, so they will have access to those cognitive APIs at that time. But yes, that certainly could be an option. And I think they are offering that, like I said, in the summer for us to integrate with.
Thanks.
Sure.
Any other questions? Seems to be lots of... here, Olaf.
When you use a public platform as a service cloud, you give up some control, obviously, right? That's part of the beauty.
Yeah.
Did you run into any issues with that they kept on changing the
Yes.
Java versions? Or?
So Michael Keeling and I worked on this together. He's snickering over there. So we were starting to investigate some of the alpha services in the same time that we were investigating these beta services. So yes, services were down, the APIs were changing, and so when we were investigating this, we had to keep that in mind, that we expect these things to change constantly. So we have to build in that mindset when we are building out our integration or solution. But yes, that is the case. It happens quite frequently. And no other way to say it than that's DevOps, I guess. So.
I also wanted to ask about the Roman riding.
Yes.
You said that both horses may fail and you may end up crashing down on the ground, but are both horses with the same strength? So is there one of the two horses that is weaker?
That's a fantastic question. I have no idea, but I guess you have to be pretty good to manage it anyway.
I mean, if you're doing cloud bursting.
The analogy goes
Yes.
so far, so.
Yes.
But with cloud bursting, I would expect that you care mostly about the private part, right?
Yes.
And then maybe you could even switch between
Yeah.
different-
Yeah. So absolutely, being able to switch between those two different cloud capabilities. So there's software out there for cloud management between multiple different platforms. I haven't had a chance to work with it too much, but yes, it does exist for that capability. Or you write your own.